Welcome back. In this lecture, we are going to learn about Hive data models. We learn about different types of table, partitions, and buckets. Tables in Hive are similar to tables in relational databases. Tables can be filtered, projected, joined, and unioned. As we saw in our previous lectures, Hive is built on top of Hadoop. So all data of a table is stored in a directory in HDFS. Hive also supports the notion of external tables, wherein a table can be created on pre-existing files or directories in HDFS by providing the appropriate location to the table creation DDL. The rows in a table are organized into typed columns similar to relational databases. Hive primitive column types are integers, floating point numbers, generic strings, date times. Hive also supports arrays and maps. Hive tables can be created as external or internal. This is just a choice that affects how data is loaded, controlled, and managed. Now let's have a look one by one. External table. So when you create an external table in Hive, you have to specify the location of file in HDFS. In this example, I have some files sitting in HDFS and I'm trying to read these files using tables in Hive. You can see the table definition here. I am specifying each column's data type, also how fields are separated in the files. This is quite similar to tables we create in traditional databases like MySQL or Oracle, except the location part, which is new here. If you do not specify the location of data at the time of table creation, then you can specify the location during load statements, as you can see in the example here. I would like to add some important points here. Always keep in mind Hadoop enables schema on read data analysis strategy. Schema on read means you do not need to know how you will use your data when you are storing it, like you are seeing in this example here. We have already stored the data in HDFS and now we are trying to create a table in Hive to read these data. The same file can have other data definitions when pig access them. If you look in traditional data systems, users decide the schema of their data before loading data into their system. For example, in RDBMS such as MySQL, you first create a table and then you load the data. But in Hadoop, your data comes first, then you think about doing analysis using different components of Hadoop. Coming back to our main topic, when it comes to reading data from external table or internal tables, select queries are quite similar to what we use in traditional database systems like MySQL or Oracle. There are a lot of benefits when you use external table. Since these files reside outside Hive, so they can be accessed by other existing programs that does not lock the files. When you drop an external table in Hive, the data remain in underlying location in HDFS. So when you fire drop command, only metadata are dropped from the Hive, not the data. When you create external table, Hive does not own data and control settings and directories. Internal table. Hive internal tables are similar to when you create a table in traditional databases like MySQL. You first create the schema, then load the data into them. As you can see in the example here, we are creating a table and then we'll load the data into it. Look at the load statements here. Internal tables should be used when data is temporary and you want Hive to completely manage the life cycle of the table and data. When you drop an internal table in Hive, both metadata and data are deleted. Partitioning in Hive. In Hive table, partitioning is done to divide tables data into some parts based on column values like date, country, region, etc. and segregate the data into different directories in HDFS based on partitioning condition. Partitions are defined at the time of table creation using partition by clause with a list of columns definition for partitioning. Let's understand hive partitioning by an example. This is a sales data. Look at the sample data here. Now we'll create a table in hive with partition based on region column. Look at the table definition here. To define a partition in our table, we have to use partition by clause and the column definition on which partition has to be done. While loading data into the table, we need to specify the partitioned column value, as you can see in the example here. Now let's have a look at some of the advantage, limitations and use cases of partitioning. Advantage: partitioning can distribute execution load horizontally. When we do partitioning, query response time is faster as it does not scan the entire dataset. Limitations: too much partitions lead to more overhead to name node. Partitioning is good for queries which uses where clause. It is not good for queries that use group by clause. Use cases: partitioning can be used to analyze log files in real time, which can help to segregate data based on timestamp. Other example would be sales record by product type or geo based. Buckets in hive. Partitions in hive can be further subdivided into buckets. So bucketing in hive is another approach to store data into more manageable parts. Look at the sample data here. Now I will create a table which will be partitioned based on country and clustered by product ID. Look at the table definition here. One more thing, before creating bucketed table in hive, you will need to run this set command. So in hive, each partition is created as a directory in HDFS, whereas each bucket is created as a file. Hive buckets enable more efficient queries. It can be used in query optimization techniques. I have attached some sample files and scripts with this course. Go and download them. Play with the sample files and try to implement what you have learned in this lecture. With this, I am wrapping up my lecture. See you in the next one.